Good evening, everyone. How are you doing?
Okay, sir.
Evening, sir.
Had a
Mhm.
early sir.
It had hurt you? Well, it should, because I should say congratulations.
Thank you.
Congratulations, congratulations, congratulations. I I can't even count by ones. I have to count by fives. So many of you from the class. I am really, really, really 100% proud of UNOS. And I pray to God that you will continue this sojourn as it's not yet finished. Not yet finished. There are two additional years, year 3 and year 4. So I'm really very proud of you. Congratulations to all students. And for those of you who were not awarded tonight, I am going to be encouraging you to just work a little harder. You may just miss it by 0.1%. All right? So continue working hard. Big up on a good self. You're proud of Uno. Always have, always will. So with that said, um, let me get the ball running. Are there any concerns, any questions? Um, I don't know if you can hear the excitement. I am. Hey, God have a sense of humor. I say that sometimes, hey, me can't play with him enough because him just. You talk about being on time. This is my little testimony. So I have been under a lot of pressure as of late. A whole lot of pressure. Not that I'm out of the woods. I'm still in, experiencing that sort of pressure. And it is because I'm teaching a kid class. And with my luck, my math exam was scheduled for the 2nd of May, which is Monday coming. And so you're a good teacher, don't reach nowhere. Well, let me not say like that. I had a whole unit, module to teach. And we started the SPAs late, and I have not taught anything for the last, well, let me not say like that. I had to teach them a topic in order for them to do the SPA. So that's all I'm doing. So I'm stuck right now because we're still doing the SPA. But give God thanks. We started the SPA last week, Friday night. Saturday morning, I pulled them into a class. Sunday afternoon after church and before dinner, pulled them into about a 1.5 hour meeting. And we have been just going. I kind of popped down, but of course, you'd have heard the good news. CXC decided to give us a 3 weeks break. I mean, not break, extension. So I'm able, I think, comfortable to finish off the SBAs with them and, put them in a good stead for them to, get a good grade and go on to the exam. So I'm just very excited. It has been my prayer, and I know that prayer has been answered. And coming back to you now, as I said before, last class, we have come too far. The last time I taught this course, was it the last time? Yes, I taught 2 groups in last school year. I taught one in second semester and one in the summer semester. My second semester, I got about I think a 70% pass. I think I got about a 70% pass in the second semester. However, in the summer semester, I got a 100% pass in the calculus 2. Partly because one of the questions that I did with the students came back verbatim. I'm hoping that something like that happens for you guys this time around. And it so happens that it is a topic that we are now doing. It came for 20 marks, and every one of the students did it and got their 20 marks, and all they had to do is just do it enough, and they all passed the course. It is my hope, it is my expectation, it is my prayer that you guys are diligent. There are a few students in the class that I'm very concerned about. Not just a little toops, but I'm very concerned about. Your class attendance, I don't speak about it, but I've been noticing your class attendance and your participation. And as I said to my CAPE students, I'm doing their SBAs on regression and correlation coefficient. And I said to them, there is a very strong positive correlation between class attendance and students' performance, right? You don't come to class, there is no way you can perform. You miss instruction, you can't catch it. There is no one other than a teacher that can explain the stuff nitty-gritty. Yes, your classmate may be able to translate what the teacher did or said, but you have to come to class to get what the teacher said. And some of you come to class, and some of you sit down, there's something kind of fuzzy, but you refuse to unmic, so it is that you can get those clarifications out of the way. But we will see what will happen. I'm really hoping for the best, and praying to God that you guys will pull through. Don't want to see any of you in no fast track class. I want you to just pass and go. Not that I'm tired of you, but I just don't want to see you again, and that's in a good way. All right. For another course, but not for calculus 2. So with that said, let us any questions before we jump into what it is that we're doing?
Yes, sir.
Go ahead, please.
Sir, I am still not seeing the recordings properly on YouTube. Is it possible for you to send us the link to them, because the times when I'm at work and to try and review the classes, I am not seeing what is being done. No, sir.
Hold on. Let me see. No, let me see if I can. All right. Give me just don't move from here. Let me just send the message right up. Oh no. Let me send it.
Also, sir, I want me the pre-Edicasoft and Mr. Somewhere say course test. What is that?
Yeah, it's just something that I put there for you to see how much you know. Right, so
Wait, so that covers the entire course?
Supposed to. I don't remember exactly what is in it, but it's supposed to. But that's not the exam doing it. It's not the. It's just.
No. I know. I'm just wondering if it is best to leave that one till the end.
Yeah. You can leave that one. You can leave that one. Right. You can leave that one. Math. And
Okay.
In 14. So you see, you're getting audio but no video, right?
Yes, sir. It is just showing the name of the participants in the meeting. It's not showing a screen sharing or anything.
All right. I just sent a message to one of my techies, a very reliable go-to person. So let's see if he responds in short time. If he does, I will definitely press pause and go. All right. Those of you who I just spoke about in terms of your class attendance, you know yourselves. I don't need to call any names. You know yourselves. You need to do what it is that you need to do. And I'm very serious about it. Now, one of the things, I can be very nice. Very, very nice. And it's not a put on nice, it's a genuine nice. But I can go from 0 to 100 in a millisecond when it comes on to tardiness, laziness, not come in my classness, not do my workness. I get very dark on that, right? Because when you do that, you are going to fail the course. Mr. Shan, why is it that you have so many failures? So they pity them. Yeah. Why not you? Right? Students will come to my class and fail. And for that, I'm rather annoyed. And that's why I'm speaking about it now. And I have been speaking about it, right? So I will pull these recordings and I'll pass on to those persons. Matter of fact, before I move on, let me make myself explicitly clear. My Edicasoft assessments should be completed before the start of your examination. Your exams will begin on the 24th, not the 23rd, the 24th. And my assignments, my assessments must be completed before then. You have a clear 3 weeks to complete your assessments, and I'm not going to be entertaining any foolishness. You don't want to hear, sir, we have 1,000,001. I don't want to hear it. There's no love lost enough, but I don't like when students procrastinate. You procrastinate and you get a C minus. What if you never did do that? You could have get an A plus. Come on. All right. So with that said, I'm pretty excited. What I ended with the class last night, not last night, you know what I mean? Oh, I didn't send you the notes. As I explained to you, it's really tunnel vision with the Cape students. So when I finished class with you on Tuesday, I went into a class with them. I know they're tired of me, but anyhow, this too shall pass. All right, hold on. Let's see if that's him who just responded to me. Oh, come on, don't do that. Okay, no. But I'll get the notes to you. Fret not. I'll get the notes to you. I have sat down and did quite a bit of stuff for you, so you're deserving to receive them. If only this computer will move as fast as I want it to do. Oh, I'm gonna ask you guys today. I'm not gonna ask you as a class. In 2 years ago, before the pandemic, I threw it out to my calculus 2 students. Students, I need to purchase a computer because I think my computer is going. And I had one piece of debate in the class, which is best, which is not good, this is that, so over and that. And I was left confused. And then the students said, sorry about the computer already? No, why, sir? Because I'm confused. I'm even more confused than when I asked you. Because what I would do is just go online, look on something, and say, well, it's expensive, so it's supposed to be good, or I never studied computing. Look to see the memory, and I said, no, I definitely have to change the system this season. So what I'm going to ask those of you who would want to assist your lecturer, I'm not mandating anybody to do it, but those of you who would really want to assist your lecturer, I'm going to ask that you find something, say like on Amazon or on Best Buy. I'm not going to entertain the conversation in class because I'm going to be left even more confused and I have to change the system. I'm going to ask you to just find something for me. And then I'm going to ask you to WhatsApp it as a closed poll. And then I will look through your suggestions and make a decision. I depend on you. You see the level work that I do in terms of preparing the notes and the heavy typing and the software, whatever the situation is. So I am really thinking of it. Also, I need your assistance because I am in two minds whether or not I should just buy, we call it an iPad Pro versus just getting a laptop. So you can tell me whether or not I should get a laptop or get the iPad Pro. Please do not tell me to get both. I'm a teacher. So just help me out, please.
Sir, what do you mean? You're head of department, sir. Stop lily down the title.
All right, then I hear you. It's more tech than anything else.
Sir, see, I have a suggestion already there.
I have a suggestion. I don't see it.
in the chat.
Or in the
Make
chat.
that 2, sir.
Make that 2. All right. All right. So let me see
So you
what
have
we
a
have.
second screen?
If I have a who?
A second screen, a monitor, and
You know, Kerry. I spoke to Mr. Pinnock about that because what I found the other day is that sometimes, and it happens a lot with you guys, more than any of the other groups that I teach. There are times I come to class and I give you some stuff because when I do the notes, I can't really write like 5 examples. Most time I'll just write like a 1 example, and I'll create a question on the spot and give you to do. And then now, sometimes you say, sir, I can't see the screen. You know why? Because I have to go into a new document to write a new question, to do it in the meantime while you're working. I'm doing a new question, then I project it. So I said to him that I need one of those expandable screens, or it's not necessary to get another monitor, but I know they have the expandable screens where you can use 3 screens at the same time. You can drag your information across. You know what I'm talking about, right, Kerry?
Sir, I don't know if I know.
Yeah, but them have them something there. Them have it available, and I was really interested in that. So you are thinking where I'm thinking, because I can't get onto my. Am I not getting onto this stuff?
Sir.
Yes,
Sir.
Yeah,
Sir.
yeah.
So, may I tell you, say no, Zin, just a quick thing. Not confused, but just a quick thing. You see, the thing we all get with the MacBook is stability, right? However, high maintenance. Because almost anything I buy fit, I'll be expensive. But in terms of stability, good. The latitude line now, it is the firmest variant of the Dell laptops. So them rugged, military tested. Understand? So them can take beating, you know, traveling up and down, whatever. You have the business class of the Dell latitudes that are thin, very thin and light. Understand? So maybe you can look at that if you want something that is portable, and they also come in 2-in-1. But believe me, nobody no HP. I don't buy no Lenovo unless on the ThinkPads.
HP is the worst.
HP,
No, HP is not the worst, you know. Lenovo.
No, not for me.
Lenovo, that piece of something, it just
not for me, Kerry. I don't know which Lenovo you bought. I have had 2 Lenovo and they have given me no problem. I only bought 1 HP and it's pure problem.
HP is garbage. HP is garbage.
Is the
exactly. Sasha have a HP, so she can tell you.
I had a HP and it mashed up within what 7-8 months.
Well, to be honest with you, I got an HP 1 January. It was presented to me at a CCCJ conference. Maybe can I take out the plastic off it? So you know, say it when you take out the plastic, what it means, it is what?
You break it in, sir?
No, man. When you take out the plastic.
Oh,
it's no longer condition, sir. It new, but
it new. When we say new, it's brand new. You see, by the time we drive up from country and come into Kingston, computer work well enough, can be excited and computer charge and use computer. You know. It's about 2 weeks after that. Is a blue screen on the computer.
Blue screen of death.
With a you know the sad face to say something, and this is taking a while and reboot and so forth. That computer has not turned on 2 weeks after I got a brand new computer. That was a HP.
Yeah, man, blue screen of death, that man.
Yeah. So all right. So thanks. I'm seeing quite a number of people saying this Dell Latitude, and I'm seeing all right, so what I want you to do for me, Ryan and Lexton, and those of you who are saying the Dell Latitude, what I'm going to ask you to do. Oh, but Rasheen, you're also saying Dell. So
yeah, man. It's the one that I'm saying, sir. That's the one that I want to buy, because the work that I do, oh my God, and then the work that you do, trust me, it will suffice for it. It will work.
Wow, Jesus, $1,700. Whoa, I shall walk up and down with my hat. Yeah, I shall walk with my hat. No, but I mean, it's important though that that I can just get something.
Yes, sir. I can guarantee you.
So this is a lot. This is a latitude, Rashim, or is something different?
Something different.
Oh,
Maybe
something
different from what
From
Ryan.
what you're saying. Okay, all right. So Lexton, do me a favor. Send me. I'm gonna keep this page up because I now need to start looking around. My all right. So I need to 1006. All right, and it is hard disk drive is 512. Not bad. And it's 1T, 130. No, it's 500. Okay, not bad. All right. So please, thanks for those of you who came to my. Oh, and it is full 360. Nice. 32 gigabytes.
Share your screen. Let me see which one you're looking at. Amazon. Sorry. This is the Dell 9310.
Nope.
No, don't get that. You see why I tell you.
XP slide is no longer good, sir. Everybody apparently. You can't check the reviews. I will see. And
Okay.
plus, sir, if you are going to spend $1,600, might as well buy a MacBook straight up.
Yeah, I was gonna say that, you know, that money that's not like MacBook money.
All right. Let me see the. Which one you said? Which one? And listen, I mean, two more minutes before
The XP slide was good enough. Maybe that's why
the XPS are the expensive one, you know, sir.
Right, but there are a lot of issues nowadays.
To me, the Latitude, them are more of the business grade laptops. So them they usually last a little longer.
Exactly. Thank you, Mr. Davis.
Oh, the business laptop, 2021 newest Dell business laptop, 1,218. Well, that's another one. So that night price now still, you know, could talk truth. 16 gigabytes.
Having money, yeah.
Okay, you know, I'm not gonna get paid, you know, man, you know.
Just add 2 to the card for me, please and thanks.
Sure can. I can add a whole 21.
Why you take the words out of my mouth?
I can add the whole 20 something.
That Andrew.
All right, so no, it's when we say $420. No, that's renewed. I don't want a renewed something. No, just renewed. All right, so it more look like that.
Amazon renewed good still, no?
No.
The poor man budget.
No, no.
Sure. This is something, sir. You see, if you like it, yeah, well, you're supposed usually Dell site have it like cheaper, you know. Like if you sit down one day and you like it, you can probably check the Dell site and buy it straight from them.
And buy straight from them.
Yeah.
And you probably get a warranty, though.
Yeah, you get warranty from Dell, and Amazon supposed to give you a warranty. So, but sometimes Amazon kind of, you know, say they we are Jamaica and nothing, and them say send it back. You can probably just buy it from Dell.
Okay. All right. Dell Latitude. All right. I think I kind of look sleek. All right. So again, add it to the card so I know that it's there.
Sir,
all right.
two.
I forget to put the number the second. I'm going to press the plus sign and then increase the number of it. All right. Thank you, guys. All right. So so I am very proud of me asking you guys a question on the double second order partial derivative, and you know, to see you guys do the second order partial derivative, it was nice. It was very, very nice. I really I'm very excited about it. I think this was a question that we did, and you got that. So what I'm going to do now is I'm going to be projecting this question: f of xy, 2xy plus 5x squared y minus 6xy squared, and I want you to find the second order partial derivative of both, right? So remember, just as a recap, remember To find the second order partial derivative of f of xx, remember you must find f of x first, differentiate it a second time with respect to x in order to arrive at f of xx. I'm giving you this one question as a warm-up, and then I'm going to jump into the cross-order partial derivative and take 5 minutes and do the cross-order partial derivative so that we can jump into a full question. I'm really interested in the full question now. All right. So 2 minutes. I'll give you 4 minutes to do this one. Start from it, please.
Sir, SODE is the same as SOPD?
Second order differential equation supposed to be second order
Partial
derivative. Yeah. Same difference. Yeah, man, same difference.
Hear me a while ago from this.
No, man, it's the same difference. All right. Should be finished by now. I'm here and I don't hear not even a breath taken. Are we finished?
So I was about to direct message you, know, sir.
Finish? And anybody has finished? So Yannick is finished. Anybody has finished? All right. I'm seeing one other response. Good.
Finished, sir.
All right. Nice. Thanks.
And I
Andrew.
finished though.
Nice. Very nice. All right. Okay. You guys are supposed to be honest students. My first order partial derivative for x and y are projective. Agree, disagree? If you disagree, let me know, please.
I agree with it, but I left out something.
Agree, sir.
Nice. Okay, good. Nice job. Nice
Agree,
job.
sir.
Yes,
All right, I hear a come talk to teacher.
No, it's a simple mistake, but I am half here.
Okay, so you see a mistake and you understand it.
Yeah, yes, sir.
Okay, nice.
Sir, I
Nice.
did everything, but I never wrote 6y squared for some reason.
You have to. All right. So I'm seeing the different messages and
The whole thing I left off was the y for the 10x.
yeah, man, but yeah, so you recognize the y is going to be very, very critical. All right, so I'm happy for that. And then now the second order partial derivative. Yes, man. I'm seeing the responses. Yes. ABC. That negative sign is important to hear.
Yes, sir. Yes, sir.
Yes, sir.
All right.
Sir, why you not let go from my shirt?
Sir,
I love it. Yes, Papa.
tell me how you get the 10y and the negative 12x.
I'm more than happy to.
Can I explain, sir?
Oh, absolutely,
Well
ABC.
done.
Absolutely, ABC. Go right ahead.
Okay. For the first order, you're going to be differentiating by x. So because there's no x in 2y, right, this will be basically phased out. And now, yeah, and the same thing with the one at the base as at the last end as well. So now when you're differentiating 10xy, right, so you'll differentiate the 10x, which will bring down to x 10, and you just bring back the y, so you get 10x 10y.
Very good. Very good.
Right.
Very
Should I continue, sir?
Absolutely. Why not?
Okay.
And
Yeah,
then
and
next
because
one.
you're doing by y now for the next one, right? Both the ones at the front, the ones with the x at the front, will be differentiated out, and then 12x you'll bring it down. Now the y would actually differentiate back to 1, so it will just come back to 12x minus
Remember,
12x.
okay, thank you.
Sorry, sir.
All right, very good. Very good. So he says will be differentiated out. What it is that he's saying is that the differentiation of a constant is equal to 0. But yeah, very nice. Love it. Love the sound of it. All right. Let me answer. Go again. Yeah, go, Brian.
All right, you're rest of it confused also. You mean like a married and single argument there, and this one you kind of get mixed up.
Why from?
Because I was looking at now, so that 2xy, I drop it because I'm saying that married.
2xy, there's no 2xy there. Oh, in the original question?
Yes, sir. So when I'm doing the first order, I dropped it because
no, hold up. We did in the first order which one? First order with respect to x or with respect to y?
X, sir, X.
Okay, first order with respect to x. When you're differentiating this first order with respect to x, because it's married, it means that the y has to be written back. See it right here, so? And then I'm going to differentiate the 2x to give me 2, so it becomes 2y.
Okay, all right.
And similarly, when I'm differentiating with respect to y, my 2x is constant, so I put it back. And the differential of y is going to be 1. So 2x times 1 is 2x.
Okay, all right. And this one we get mixed up.
All right. Not surprised that you fair enough, Papa. Fair enough. Not surprised that you are, but can you tell me exactly where?
Where I got mixed up?
No, not you. Okay. No. But by the way, you understand, Ryan, what I just explained a while ago?
Yes, sir. Yes, sir.
Okay, cool. AJ, I need to hear from you. Okay. All right. So let me go to the first order partial derivative again, please. And this is for those who are not fully understanding, and for those who understand, I want to just fully concretize it, seal it, because I'm moving from here into my cross order partial derivative. I am very excited to do this, to finish, but I have to finish off this question, this topic tonight, because it's one of the topics that I know will be coming on the exam. It must come, it have to come, it is always there. If it is not there, I will be, if it is not there, I'm going to say that the paper is poorly written.
Or if it's not there, call him and tell him to do it paper.
Yes, sir, please. As well, look for the local marks.
Talk true. Let's go. So you're given a function f of x. F of xy is a multivariable function, not f of x. F of x is a single variable function. But f of xy, the multivariable function, is equal to 2xy plus 5x squared y minus 6xy squared. They're asking us to evaluate f of x of xy and f of y of xy. No. F of x of xy has to be done in two phases. You must first find f subscript x, and then go ahead again and differentiate f subscript x with respect to x in order to get f subscript xx. What am I saying to you? This here, had it been a single variable function, it would be that I'm finding the second differentiation. This here, as a multivariable function, says that I'm finding the second derivative. In order to find the second derivative, I must first find the first derivative and differentiate the first derivative once more in order to obtain the second derivative. So differentiating it twice will give me the second derivative. Very important, right? You know, funny enough, I can't recall if it is a business calculus paper or because the business calculus students also do this topic. Can't recall if it's a business calculus paper or it was a calculus 2 paper. I see the man asked you to evaluate f of x, y, x. So you differentiate it first with respect to x, then you differentiate it with respect to y, and then go back and differentiate it with respect to x. Then so you couldn't just find x, and then y. No, that I want different something. So you have to look at the subscript, which is what I'm going to come on to next, to see what they're asking. So they can ask you to find f of xx. Why? What does that mean, sir? Mere fact that you have 3 something on it there, so you're going to the third derivative. But sir, we never do the third derivative. Well, if you can do the first derivative and the second derivative, you can do the third, the fourth, the fifth, the sixth derivative by differentiating this many times over. Matter of fact, we have done up to the 5th derivative when we were working with Mr. McLaren. So remember, Mr. McLaren, so you have to go as many derivatives as the coefficient that they asked us to calculate. So yes, we have done multiple differentiations. All right. So let's go. So what I said to you is, once you're married, it means that I cannot throw out any of the variables, irrespective of what. Irrespective of what. So what do you mean by married? What I mean is when I have a product, x times y. When I'm single, for example, in this case, when I'm single and I have just y, it means then that once I'm talking about x, this here goes to 0. But when I'm talking about y, I'm speaking to this directly. So it stays. When I move here and I'm speaking about y, it goes to 0 because there's no y. But when I'm speaking directly to x, it remains. So when you're married, whether or not I'm speaking to you, you are there. When you're single, if I'm speaking to you directly, you remain. But if I'm speaking to the other one, take for yourself. That's all I'm saying. Let's go. I'm differentiating here with respect to x. F subscript x of xy. It means that my y is going to be a constant. So I'm taking my y and I'm putting my y here. And then I'm going to be differentiating 2x. The differential of 2x is going to be 2. So therefore it now becomes 2y. Similarly, 5x squared y, because I'm differentiating with respect to y, with respect to x, my y is constant. So I'm going to write it back first. See it right here, so? I write it back right here, so. And then now I'm going to be differentiating my 5x squared. The differential of 5x squared is going to be equal to 10x. and I just put the 10x in front. So we're going to put the 10x after. You know, in mathematics, we're writing chronological order and alphabetical order. So because x coming for y, I put xy. But sir, suppose I go in the exam and put yx, would that be right? Yes, it would be, right? But you know, we just fixed up nice-ish. Yeah. And then differentiating this again, similarly, it's married, it's a product. So the variables don't just disappear like that. I'm differentiating with respect to x. My y is constant, so my y is written back. So I have my y squared here. And when I differentiate negative 6x, I'm going to get negative 6. And that's why I have the negative 6 here. And then some students said to me last time, sir, you know, I never found f of x, f of y by first, or f of y next. I just continue start doing f of xx. You will see me do that on the in class here too. So it's not a problem. So f of xx, you know, and that's why I said to you what I said to you the other day. But anyhow, proud of you, but I can get so much more out of it if only you do what it is that you're supposed to be doing. And I'm responding to a direct message, guys. So, all right. So let's go. So I'm doing my f subscript xx. When I'm finding my f subscript xx, it means that the first one is what I have to use, and then I'm differentiating it with respect to the second one here. So what it says, in order to find f subscript xx, I'm differentiating this function now with respect to x. And as ABC said, the truth is, because I'm differentiating this one with respect to x, and this one is single and there is no x, it goes to 0. Why, sir? The differential of a constant is equal to 0. So this now becomes a constant because I'm talking about x and not y. I'm talking about x, it means that the y is constant. But remember, this one is married, it's a product. So this y is going to be written back right here, so. And then I'm going to differentiate the x term, which is positive 10x. When I differentiate 10x, I'm going to get 10. So it becomes 10y. And then because this is y, the differential of a constant is going to be equal to 0. So it's only 10y. Similarly, let me now go ahead and differentiate the function with respect to y. It's a product. I'm differentiating with respect to y. So therefore, my x is a constant. My x is a constant. So I'm going to write out my 2x. See it right here, so? I write out my 2x. And then I'm going to differentiate now the variable in y. The differential of y is 1. So 2x times 1 is 2x. Similarly, I have this function here. My x is a constant, and it is married. It's a product. So because of that, I can't throw out any of the variables. So my 5x squared is going to be written back here. Boom. And then I'm going to differentiate my y. And the differential of y is 1. And 1 is a multiplicative identity. 1 multiplied by anything equals anything. So I'm going to have 5x squared. Again, here, I'm differentiating with respect to y. So it means that my x is constant. So this negative 6x is going to be written back. But sir, you don't have it written down there. Okay, no problem. I'm a it. It is written back. I'm going to differentiate y squared. I'm going to get 2y. Now 2y times negative 6x. 2 times negative 6 is negative 12. And x times y is going to be xy. So this comes back to negative 12y. All right. Differentiating this with respect to y again. Now, this is a term in x, but I'm differentiating with respect to y, so it goes to 0. Similarly, this is a term in x, but I'm differentiating with respect to y, so this one also goes to 0. This is the only term that is a product. That means something will remain. I'm differentiating this function with respect to y, so it means that my negative 12x is a constant, so I'm writing it back. Remember, this sign here is married to this term negative 12x, eh? So it's a negative 12x, right? I'm going to differentiate the y and I'm going to get 1. So 1 times negative 12x is going to be negative 12x. Understood now?
Yes, sir.
All right, great job. Great job. Now, as I said before, I have enough questions. I have many questions. Let me make reference to this one, because I don't know how they're going to be giving you, and I don't want the convention to mess you up. It says, given that f of xy is equal to all of this function, evaluate squiggly f of xy over squiggly x. It means say you're differentiating this function with respect to x. You can do that for homework. All right. So this convention. Now, you notice I gave you in this one here, I gave you f subscript x of xy. This one don't have no f subscript f of xy. What this says, squiggly, the function f of xy, squiggly x. It means that I'm differentiating this function with respect to x. Now, squiggly xx means that I'm finding the second derivative with respect to x. Squiggly over squiggly, squiggly of a function over squiggly y. It means that I'm differentiating the function with respect to y. First order differential. Squiggly yy means that I'm finding the second order differential equation. So this here is equals to this convention. This piece here so is equals to this convention. Xx, this piece here so is equals to this convention, and this piece is equals to this convention. Can you see that?
Why, sir, they can make things look difficult.
Yeah, I know. It's just because it's big school maths, that's why. But,
Sir, can you go again, please?
all right, no problem. No problem. Let me tell you what I'm going to do. Copy. Oh, I already have it. So what I'm saying to you, f subscript x of xy is the same thing as asking you to find squiggly f of xy of squiggly x. F of xy is the same thing as asking you to find squiggly of f of xy of xx. Them two something here tell us the same something, eh? F subscript y of xy is the same thing as squiggly of a function, squiggly y. Why you keep calling it squiggly, sir? This looks like a D. Talk truth.
Upside down Q, sir.
Upside down Q. All right. Yeah. So this one here, you know, we talk about dy by dx. This I don't want to say it, but deformed D is saying that it's a partial derivative. When you see the D looking like not well formed, it means that's a partial derivative. So f subscript y of xy is a partial derivative with respect to y. See here? Squiggly y. F of yy of xy is the same thing as a partial derivative of f of xy. It means that I'm finding the partial derivative of this function with respect to y twice. That's all that it is, right? And you see, this is one of the things that is happening to me. That's why I know the system is going. Every time I copy and I'm trying to do something, it takes quite a while, honestly. Let me just show you something. I know I'm blocking the screen, but let me just show you something. Is when I have a function like that, d of 2x squared plus 7 dx, this is saying to me that I'm differentiating this function with respect to x. Now, no, I could say, or y is equals, what was it? 2x squared plus 7. That's it. All right. So look at this. So let me put this up here. So y is equal to 2x squared plus 7. Find dy by dx. This is one way of answering the question, but I can also ask the question this way. D of 2x squared plus 7 over dx. It means that it's asking me to differentiate the function 2x squared plus 7 with respect to x. So this here, me saying to you, y is equal to 2x squared plus 7. Find dy by dx. Find the rate of change of y with respect to x. Or I can simply say d of 2x squared plus 7 over dx. It means that I'm differentiating this function here with respect to x. Similarly, is what it is that we have here, right? You know, I can put this up here, or I can put this or I can put it to the side here. It means that I'm supposed to find the derivative with respect to this here. That it's just notation, and I want you to know the notation should, in case you're going to the exam and some mischievous person decide to write the paper giving you something like that and you don't know. All right, so that's exactly what it is. All right, that's exactly what it is. All right, I think I spent enough time just explaining that. Let us move. Those are examples that I.
So, sir.
Yes, Papa.
SOPD, SODE, they are the
Yeah,
same
man,
thing?
they're the same thing. I'll change it and just be consistent.
All right, cool.
Second order partial derivative, I have a DE up here. I'm just going to be consistent and just put so second order partial derivative, first order partial derivative. It's supposed to be partial derivative, all right? Partial derivative, partial derivative, partial derivative, partial derivative.
So it's supposed to be D, not E.
Oh yeah. Thank you, Puppy. Second order partial derivative. Right. All right. All right. So those are examples that, as I said before, you'll have those to work on for me. I'm gonna send you the document, so you'll have them to work with. You have them to work. I want to move to the second order partial derivative and cross partial derivatives. All right. So let us go to the cross order partial derivatives now. All right, here it goes. So as I said before, all these examples up here, you're going to get them, so it is that you can do them on your own. It's for practice. All right. Okay, so let's go. Now, do me a favor. I'm going to give you yet another question. As I do know, I want you to find both first and second order partial derivatives for me. So that means you're going to find f subscript x, f subscript xx, f subscript y, f subscript yy. You're supposed to be better at this now, so I'm going to give you, all right, I'll give you 5 minutes to do all of them. Start with, please.
finished, sir.
Great. All right. I'm seeing the sorry. I'm seeing hold on. I'm seeing the responses coming in. Thank you, thank you, thank you. All right, okay. Let me just fix up something here, please, guys. I have OCD here, so. Go ahead now. Everybody see that? Everybody agrees with my F subscript X? Yes.
Yes, sir.
Okay, here you shall, but then how would you get that one there? Yeah, I can explain that, but that other person, check that 48, please. The plus 16 is correct, but check that 48. All right, I'll explain how to get the plus. Go ahead.
All right, never mind.
All right, good. Yeah, man. Oh no, it's not. It's not. All right, so I think that clears up your responses. All right, great.
All right. I dropped the marks, I don't know why.
And they can't. They can't. They can't. Yeah, man, they can't.
Are the 8y square, you know? The 8y
yeah,
square.
Man, it show me off.
Show me off. Wicked. All
right, never mind. Come, let's go through it quickly. So f of x, y, and that's why I wrote several questions for you. So I mean, those questions that I have up top, you're going to work through them. And I mean, I did the solutions also. All right. So f of xy is equals to this function here, 6x squared y minus 4xy cubed plus 8y squared plus xy. We're asked to find the both first and second order partial derivatives. All right. Now,
sir, before you continue then, is it because no x no day no the 8y square? So would I classify that as a 0 times the 8y square, something like that?
It depends. Let me get there. When I get there, just tell me if when I reach there, just tell me right there, sir. All right?
Okay.
Please. Yeah, cool. So I am doing f subscript x. I'm differentiating the function now with respect to x. So because I'm differentiating with respect to x, and this is a product, I'm going to write back my y. This y is this y right here. So I know there are others of you who fully understand copying. But for the sake of those who are trying to understand, bear on. So this y is the same y there that I'm writing back. So why did you write it back? I wrote it back because I'm differentiating with respect to x. So my y is going to be a constant here. And because I am differentiating, and this is a product. So I can't throw it out. It's married, I can't throw it out. So I'm writing back this y. Then I'm going to differentiate now 6x squared. The differential of 6x squared is going to be 12x. So it now becomes 12xy. All right. Similarly, this y cube, I am writing back. I'm writing back that that y cube. Why am I writing it back? Because I'm differentiating with respect to y. I'm differentiating with respect to y. To x, I'm sorry. Differentiating with respect to x, and it therefore becomes it becomes a constant. All right. So this is it. Now this other term, I'm differentiating with respect to x, my y cube, and it's a product. Only when it's a product you carry it down. Only when it is married, you carry it down. So this is going to be, y cube. So I'm writing back my y cube. See it here, so? So when I write back my y cube, what I'm going to have now is a differential of negative 4x. And when I differentiate negative 4x, I'm going to get negative 4. Put my negative 4 together, it now becomes negative 4y cubed. Now, here what is happening now. This is single. I'm differentiating with respect to x. This is a constant. It goes to 0. 0. All right. Here is a product. My y is constant. I'm writing back my y. And then I'm going to differentiate with respect to x. The differential of x is 1. So 1 times y is y. I'm now finding the second derivative of this with respect to x. All I can tell you is all of them single one here with y alone, then we go to 0. The one here, we go to 0. Why, sir? Because this is only y, so it's 0. This is only y, it's 0. This one is both x and y. This one is x and y. So this one is not going to go to 0. Not going to go to 0. So let's go. I'm differentiating with respect to y. I don't have to do that. Yeah, let me do it. I'm differentiating with respect to y. So my y is constant, so I'm going to put it back. And when I differentiate 12x, I'm going to get 12. So my answer is just 12y. And then somebody knows. I hear somebody breathing heavily. Go ahead.
All right. So how I look on it now, sir, is that when we are working with x, y is a constant. So if it's not married, then it's always equal to 0, and then vice versa when we're working with y.
Hold up. It's right. So if it is married, you carry back something. But if it is single,
but if it's not
right,
married, then it's a constant and it
but
equals.
hold on. So if it is single, and I'm differentiating with respect to x, the y becomes a constant and it goes to 0.
Yeah, that.
But if I'm differentiating with respect to y,
it's the opposite.
Right. So if you tell me opposite, I know you understand fully. Yeah, man, I know you understand fully to say it like that. All right. Now let me explain the 16 now. Somebody's asking to explain the 16. I saw a 48, but the student said to me that, sir, I thought it was something else. Okay, fine, forgive you. Let us differentiate here with respect to y. Yeah, with respect to y. Yeah, man, I'm correct, with respect to y. So I'm differentiating with respect to y. Now, all of this here, my 6x squared becomes a constant. So I write it back. And when I differentiate my y, that is in blue, the differential of y is 1, which is this. My 4x, negative 4x even, is a constant. I write it here, negative 4x is a constant. But when I differentiate y cubed, I'm going to get 3y squares. See it here, so 3y squares. I'm differentiating this with respect to y. No, it is a constant, but it is a right constant that I want because I'm differentiating with respect to y. So I can't throw it out, I have to use it. So it now becomes 2 times 8, 16y. See it right here, so. I'm differentiating with respect to y. So my x is a constant, it is married, so I can't throw it out like that. So the x is going to be right here, so, and then I'm going to differentiate my y. When I differentiate y, I get 1. It's right here, so. 6x squared times 1 is 6x squared. 4x, negative 4x times 3y squares, negative 12xy squares, 16y, x times 1 is x. This is not the answer for this one. When I differentiate here, with respect to y, this 6x squared is a constant, it goes to 0. My negative 12x is a constant, but it's married, so I have to write it back. Then I'm going to differentiate 2y, y squared, to give me 2y. Differentiating this respect to y, I'm going to get 16. I'm differentiating this respect to y, it's a constant, 0. So I'm going to have 2 times negative 12 is negative 24, xy times 16, plus 16. Are you seeing it now? Okay, very nice. Yeah, got you. All right. So now, so I'm now doing the second order cross partial derivative. This is something new. Pay special attention. Just the concept, just the notation rather, because the concept remains the same. Just the notation, the concept remains the same. Notation, the concept remains the same. Watch me. You must use the first derivative of the original function in order to evaluate the following. Now, my cross
I'm sorry, sir. Could you repeat what you just said a while ago? You said your first something.
Oh, you have to use the first order. You have to use the first order derivative in order to work the cross order partial derivative.
Oh.
So my cross order partial derivatives will look something like this: f of xy, f of yx, xy. So I'm using is a cross order partial derivative. You can understand why it's called cross order now, because in one case I have x, y, and in another case I have y, x. Right? Very important, and I want you to pay special attention to this. Watch me. Oh Lord, where am I? Watch me. Now, all right, so I'm recalling what my f subscript x and my f subscript y equals to, so that you can see what is happening here. Now, watch me. Don't blink. If I'm trying to evaluate f subscript xy, it means that I have to use f subscript x and then differentiate this with respect to y in order to get the xy. So the first one tells me what it is that I have, and the second one tells me what I'm now differentiating with respect to. So when I'm finding yy, it means that I'm using y first and then differentiate with respect to another y. Xx says that I'm differentiating with respect to x. I mean, I have f subscript x and I'm differentiating again with respect to x. Watch this one. Order is important. To evaluate f subscript xy, it means that I have to use rather my f subscript x and then differentiate that with respect to y. So that's why it's called a cross order. So instead of differentiating this with respect to x again, I'm going to differentiate this with respect to y. Instead of differentiating this with respect to y, I'm going to differentiate it with respect to x. I'm doing the cross of it. I'm finding the cross order partial derivative. Right? I'm finding the cross order partial derivative. All right, let's go. So, so f subscript x, and I'm differentiating with respect to y. Differentiating with respect to y, it means that my x is going to be a constant. So I'm going to write back my 12x, see it right here. So I'm going to differentiate it y, I'm going to get 1. So 12x times 1 is just 12x. I'm differentiating this with respect to y because I'm finding xy. So I'm differentiating with respect to y. So it becomes 3 4 12, negative 12y squared, negative 12y squared. And the differential of y is going to give me 1. Similarly, it's a cross-order partial derivative. So f subscript y of xy, in order to get f subscript yx, which is this, I have to differentiate this function now with respect to x. And I'm going to get 2 times 6 is 12x, which is this. When I differentiate this, it means that my y is constant, my y squared is constant, I put it back. And when I differentiate negative 12x, I'm going to get negative 12, so it becomes negative 12y. I'm differentiating this with respect to x, so that means this 16y becomes 0, but the differential of x is 1. I want you to spend 2 minutes to look at that. It's the same differential between, but this one is a cross order, so you have to write. Matter of fact, it's so important it is now for us to label what it is that we write in the count. Just go ahead and do the differential and don't write the subscript x and the subscript xx and y and yy and xy and yx. The story not finished yet, you know. Matter of fact, what do you recognize with f subscript xy and f subscript yx?
Sure. Is it a case where the letter, the subscript letter that is at front, that is the constant?
Yes.
Yes.
But I heard you look at the first
This
like
one here?
12x twice.
No, this is a constant, so I write it back. So the first one that is no you're going to be holding as a constant to differentiate with respect to y.
So the first is the constant, the second
In
is
this-
how we do the derivative from.
Right.
Mm-hmm.
Yes.
Okay.
Yes.
All right, I'm work on that.
All right. You love the sound of that. No, but before you do, before you do the one, man. What do you recognize with f subscript yx and f subscript xy?
It's kind of equal the same thing.
Same thing.
Now hear me out. I don't know who other teachers teach, but I know who I teach. And I'm going to give you an example. And you're going to do the example, and then I expect to get some questions from you. But guess what? The example that I'm going to give you is not to find just the straight cross order partial derivative. No. I'm going to give fresh questions. So you have to go through f subscript x, xx, y, yy, xy, yx. So those are the 6 calculations now that I expect you to do. So those of you who never catch the first part right, catch it now. 5 minutes.
So, sir, this is where the 20 marks come in now.
This gone about 8 marks so far.
Where?
All right. Come on, start.
You say you want fine.
Yanni, press mute. It's not hard, man, Yanni. I promise you. No, I'm serious.
Sir,
No.
sir, we not reach out part yet.
No. I promise you. No, guess what? All right. Let me put
All
on
them
the-
word up that it seem important this time.
No, is it to be honest with you? Them word up there. I don't want to discourage you, but no. On a serious note, I just switch on the serious mode. I'm still going to be saying to you that the topic is easy. You see this cross order partial derivative? The only thing that is new to this cross order partial derivative is just this concept right here. That's all that there is. But do me a favor. I'm giving you this question for you to do on your own. In this question, what I expect you to do, I didn't want to write up the word up, as they call it, because it's really teaching and examples. I want you to do this question, but in doing
word up, sir.
You want write the word up?
Yeah, man, write it, sir.
In the brain from early for the final, sir.
All right, and cool, no problem. I have the word up, but if you don't want to scare the word up first, and then you go tell me
No, man, sir, I know you have to make get it, sir.
All right, then go. Okay, let's done. So I'm going to put up the word up. So this is what I want you to do for me. Here, I want you to find f subscript x, xx, y, yy, xy, and yx. So every time you see this question, remember that you have 6 differentials to do. F subscript x, f subscript xx, f subscript y, f subscript yy, f subscript xy, f subscript yx. All if you don't know where the question I ask you to do. When you read up the word up, and then tell it this and then tell it that, you don't have a clue them at all about, catch your function and start to work it. X XX, Y, 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 XY, YX. Right there, so then you pick up at least 6 marks. Real talk. Start. On the mark, get set, go.
Sir, that'll go be the case all the time?
Thank you for the conversation. Every single time. Every single time. But guess what? Let me caution you on something. Do not just find one and then just write it back and say, you're not going to find the other. Let me tell you what it is. You see, when you find f subscript xy, and then you go ahead and find f subscript yx, and you get the pair of them coming together to be the same thing, it means that the other 4 calculations that you would have done up top are correct. That is a true test to see if you're right. If something is wrong with one of them up there, it means that your f subscript xy not going to come out to be the same thing as yx. So I keep saying to students, go ahead, calculate f sub. Sometimes the exam will tell you to calculate 1, me calculate 2 of them, because I will know if my answers are correct by getting the same answer for f subscript xy and yx. Yes, you will get the same answer every single time, barring none. Every single time. All right? Every single time. Everybody
Sure.
finished? Go ahead.
No, sir. No, sir. Give me about 2 or 3 more minutes.
All right, cool.
For the xy and the yx, we're going to use the xx and yy to do that.
Not the XX,
Single one.
the
The
single
single
one.
one. Okay.
Yeah.
Sir, what am I saying? You can look on that.
So, sir, excuse me, sir.
Yes, Papa.
You're saying that we should do the yx as well?
Yeah, man.
Okay.
All right, this is when I respond to you and I put COPD is across other partial derivatives here. Well, you should know this.
All right, finish, sir.
I'm giving those 2 guys another minute. All right. Really very proud of you. Really very proud of you guys.
Sir, hold on,
Yes.
I'm just sending a message. I tell me if me have.
All right, no problem. All right, send it now because I've been project the answer now. So send it right now. Okay. All right. Okay. Looks okay.
Center.
Are you okay?
Big up, big up, big up.
Big up yourself.
One and move.
Good self. Good self. Very nice. I am looking at something here though because I was seeing a +1 somewhere. All right, just give me half a second. Let me just go back and check something. All right, okay, so are we okay? Is there anyone that needs for me to?
Yeah, you can just run over C.
All right, no problem. What temperature of a C? Shout it, just talk to me. Where you get the C?
Sir, me not partially have it. Me get the 10x, but me never get the 12.
Okay, all right. I thought you got something else because I'm responding to okay, nice. I'm responding to messages as I go along. All right, so let's go. I'm differentiating with respect to x. So it means that my y is constant. So this is going to be 5 times 2 is 10. So this is going to be 10xy, which is this. My y is constant. I kept up my y squared. The differential of 6x is 6. So I'm going to have 6y squares, which is this. I'm differentiating this with respect to x. So this becomes 326x. But this here is y, stands alone. Differentiating with respect to x, it becomes a constant, 0. And then when I'm finding the derivative now of f of xx, I'm differentiating this with respect to x. Y is a constant, I put it back. Differentiating 10x, I'm going to get 10. Differentiating this with respect to x is a constant because it's only y. And when I differentiate 6x, I'm going to get 6. For y, when I'm differentiating the function with respect to y, 5x squared is a constant, so I put back the 5x squared. And the differential of y is 1, so I just put the 1, so I'm just going to have 5x squared. When I'm differentiating this, 6x is a constant, so I put back my 6x. But when I differentiate y squared, I'm going to get 2y. 2y times 6x is 12xy, which is this. I'm differentiating with respect to y. This 3x squared has become a constant. So I'm going to differentiate negative 7y to give me negative 7 here. And then when I differentiate yy, this is a constant because there is no y, so is this last term, so this is the only one here. So 12x is a constant, I put it back. And when I differentiate y, I'm going to get 1, so 1 times 12x is simply 12x. When I'm differentiating f subscript xy, it means that I must look for f subscript x, which is up here. And then I'm going to differentiate this with respect to y. 10x is a constant, and the differential of y is 1. So 1 times 10x is going to give me 10x. Go back to the function, and I'm differentiating with respect to y. 2 times 6 is going to be 12x. 12y. And I write my 12y. When I differentiate 6x, the differential of 6x with respect to y, the constant is at 0, so it goes blank. And similarly, to find f subscript yx, it means that I have to use a function f subscript y to differentiate it with respect to x. See here? I'm using y, and I'm differentiating it with respect to x. When I differentiate it with respect to x, 2 times 5 is 10, so I'm going to get 10x right here. differentiating this with respect to x, it means that my y is constant. Right, but my y, differential of 12x is 12, 12 times y is 12y. And the differential of a constant here, negative 7 is going to be equal to 0. And these will be my differential. Always, every single time, will be equal together. One more as a try.
Yeah, man, run it, sir.
All right, here you go. Final one, and then we'll move into the question, full question.
So what is WRT?
With respect to y. WRT is with respect to.
Full question, sir. They like this.
Well, there is a final part of the, well, there are two more parts of the question, and that will give you the other 10 marks.
I realize it's a step, sir.
Yeah, man, it is. But I really want to finish these two parts in class tonight. Really want to finish it. All right, start from it, please. On the mark, get it go.
Sir, that notation that somebody just asked about, what was that in regards to? The same CO that we just did?
Right. So I was just saying that, we're using the function in x to evaluate, with respect to y. So this is related to that. Yeah, man.
Sir, we still like a test this evening?
I'm ready. Are you ready? You want it today, or what should I do? Should I break and give it to you now? Tell me what to do. Talk to me now. Yes or no?
Yeah, we finish groups, sir.
All right, finish the question and then tell me. Think about it, finish the question and let me know. I really wanted to finish off this thing here, but let me know. I mean, the paper is I have the paper available, and let me know. Finish off this question first and then let me know.
So I'm up the next step just as easy as that step here now.
I think I'm finished, sir.
I guarantee it's going to be very nice ABC. I guarantee you it's going to be. I guarantee you. And you see, you notice what I'm doing? I am not only asking you to calculate the cross partial derivatives, the COPD, I'm asking you to calculate everything. So each time I give you the question, you're getting your practice. You're getting a practice. All right. The rest of you, come. Ryan, how you stay? Nice. Have you not talking to teacher tonight, Davia? From Tuesday, I'm calling her Davia and come back to me, you know.
Yes, fine.
Nico, talk to teacher, please.
Sir, not finished.
Continue working.
Sir.
Yes, hon. Finish, Charles?
Yes, sir. I just let her finish.
Okay. All right. ABC, me can't tell you say you catch that topic here. Me not ask nobody. Me can't tell you say you catch it. The one here is good for you.
I have 2 more steps, sir.
Talk truth.
May I wait for the rinse, you know, sir? May I wait for the rinse?
Hold on there.
Sir, I'm finished now.
Hey, sir, me get something shaky I saying. Sir?
Yeah, man. May I hear you, man?
All right. So the first one I feel right, but the second one, the thing that changed from Y to X.
From Y to X?
Yeah, man.
What changed?
All right. So me get for the first one, I get 8y plus 6, and then the second one is 8x plus 6.
8y plus 6. No, man. The mere fact that you get something wrong, something different for the last one suggests that something is wrong. Did you get this for your F subscript X?
Which one?
Did you get this for the F subscript X?
Yeah.
Did you get x to the 4y squared?
No.
Okay. Did you get, all right, so let's go.
The second one right still not be right.
All right, let's go. F subscript X, I'm differentiating with respect to X. It means that the Y is constant. So my Y squared is going to be written back. I'm going to have my Y squared here. And then I'm differentiating my 2x squared. The differential of 2x squared is it that we're supposed to do x first, then y? All right, I'll come into you. 2x sorry, let me go again. So I'm keeping my y squared constant because I'm differentiating with respect to x, and it's a product. It's a married term. So I'm going to write back my y squared. I'll write back my y squared. And when I write back my y squared, I'm going to then differentiate my 2x squared. And the differential of 2x squared is going to be 4x. So I'm going to have 4xy squared.
So when we get your answer.
Okay, so okay, got you. And then now I'm differentiating with respect to, again, x. So my y is constant, so I write back my y. And when I differentiate 6x, I'm going to get 6. When I differentiate x, I'm going to get 1, and the differential of y here is 0. Why, sir? Because I'm differentiating with respect to x. That means it becomes a constant. Differentiating now f subscript xx. This is a constant because there's no x, it goes to 0. This is a constant, there's no x, it goes to 0. So when I differentiate 4xy squared with respect to x, my y squared is constant, so I'm going to put it back. And the only reason I'm putting it back is because it's a product. It's married. And when I differentiate 4x, I'm going to get 4, so it's going to become 4y squared. And I'm differentiating here with respect to y. My x is constant, so my 2x squared is going to be a constant, so it's there. Then I differentiate y squared, and the differential of y squared is going to be 2y. 2y times 2x squared is 4x squared y. That's why I get 4x squared y. You can see that there's a line that I didn't write. But I mean, you write in the line, you know, it will be good to go. I'm differentiating here with respect to y. 6x is a constant. So I write out my 6x and differentiate y, which is 1. 6x times 1 is 6x. Differentiation of x with respect to y is a constant, 0. And the differential of y is going to be 1. Differentiating here again with respect to y, the 6x and the positive 1 is a constant, or are constants. So it goes to 0. Differentiating with respect to y, my 4x squared is a constant, to write it back. Differentiating y, which is 1. Differential of 1 multiplied by 4x squared is going to be 4x squared. Then I'm finding the cross order partial derivative now. The cross order partial derivative. Cross order partial derivative. I'm doing the differential of f subscript x of y. Cross order. So I'm going to use the x to differentiate y. I'm going to use the y to differentiate x. So x to differentiate y, it means that y is 4x is a constant. I'm going to write out the 4x. Differentiate y squared. I'm going to get 2y. 2y times 4x. 4 to 8xy. See here, 8xy. Differentiating this with respect to y is going to give me 6. Differential of 1 is 0. And differentiating now y with respect to x, it means that my y is a constant. So I'm differentiating x. I'm going to get 8x times y, 8xy. Differentiating this with respect to x, I'm going to get 6. And both of them are the same.
My fault, man. May not divorce the marriage.
You can't do that. Can't do that. All right. So with that said, I have many more questions as you see here. Many more questions. Many more questions that I'm going to send off to you that you can sit and do. Sat down and I just was feeling very happy and I wrote those questions. And then no, this is where I'm going to go. No, stationary point. So yes.
No, sir. The little pushback I see, sir, make us feel so nice.
So the question.
Sir, what is our good news, sir?
Your good news is that again now we're going to be looking at a that you can do, we call it
A stationary point.
Stationary points. So the question is a question on stationary points.
Sir, the good news we did promise to tell us, sir.
Okay, so good news. One of them I can't, piece of it I can't tell you yet, but the other piece I can tell you. Well, I can give you 1.5 out of the 2. So the one that I can give you is that your exams will not begin on the 23rd because the 23rd is a public holiday. CCCJ never normally gives exams on public holidays. However, the external CXC exams would, run anytime because, not all the regions have the same holiday. So Jamaica celebrates Labor Day, but there are other regions who don't have a holiday on, on the 23rd. CXC wouldn't put an exam on Christmas Day because Christmas Day is almost universal. Yeah, global. So we don't do that. So I spoke with them and they said, no, that has to change because we never nominate. And I know we never nominate. So that is one. And two, well, a half is that there was something that was supposed to come to you students. I don't see it yet, but one was sent to me and I did mine. And I suspect that one may come to you by tomorrow. So just look out. Just look out. Don't say nothing to nobody. Keep it very close to your heart. Don't message no other lecturer, not say nothing to nobody. Just keep it close to your heart. It will come. It will come. Just pretend that you don't know nothings. And I guarantee you it is something that is going to be favorable. All right. So just stay put. All right, let's go.
Sorry, I feel like we still not getting good news, you know.
All right, we soon get it, man. All right.
Sir, while you look like you sort out something, I have a question. While going through the paper, I see them give with some production and some questions that look almost like accounts. That how I say them there? As it on this topic.
Yes. Do you have any of those questions that you want to share? We can just remember too. All right,
I'd have to send it in the group, but
okay.
never mention it before because I realized we never even reached that stage. So I was
right. Fair enough.
Building that.
I'm building three. All right. So let me do one little example here first, and then I ask you to pass that question on so we can work that question in class. All right. All right. So let's just move to the stationary point. This is it. This is it. So we're looking now at the stationary point of a multivariable function. The stationary point of a multivariable function. No, hear me out. You hear what Yannick just said a while ago, sir? I'm looking at some of the questions in the past week, and it almost looked managerial accounting to me. Don't know where to start. You know where you start? Catch the function. It's a multivariable function with x and y. Sometimes in here as pi, sometimes in here as delta, sometimes they don't even put f subscript x or f of y or squiggly y. They name the function however they want to name the function. Find the 6 something. Sir, what 6 something? F subscript x, 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 f subscript y, 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 f subscript x, y, f subscript y, x. You must get marked. You're gone at least 6 marks. You could get more than 6 marks. At least 6 marks. Got 6 different calculations to do. You get marks right there, so. And then we're going to move now into the stationary point because it's a question on optimization, right? So let's go. So to determine the stationary point, we get to differentiate the function f of x, y to obtain the 2 first derivatives, right? So you're trying to obtain the 2 first derivatives. The 2 first derivatives. Them 2 something here, all right? Then we're going to set the differential equals to 0. Though, sir, we did stationary point in calculus 1, and Tiana did stationary point in the other calculus course. So you can put the differential equals to 0. And Ryan did calculus 1 last semester. All right. So you can set the differential equals to 0. The one up here, so the same one again setting equals to 0, and then you're going to solve simultaneously. You're going to solve simultaneously. Now, this here, if I were to be honest with you, would be my only concern about this topic with you guys. My only concern. Only concern with the topic. Only concern. But guess what? I am confident. My only concern. So these will give us our critical values. The result together gives a stationary point, and you know this. We went through that already. Now, here what I wanted to know is the classification. The classification. The classification, now you're going to use f of x xab times f of y yab minus f of x yab all squares. So we are talking about that's something here. This is what it is that unlike the single variable function, we can find a second derivative and rate it and support and so on. And incidentally, that's why you had to find a second derivative. So this is the second derivative of x. This one is the second derivative of y. And this is a cross order partial derivative. All right. So what you're going to be doing is looking at f of xx times f of xy. So what the AB business, okay, fine. The AB is going to be your critical point. See here? Suppose that AB is a critical point. So you can substitute your critical point into your second differential, similar to what you do for the single variable function. You're going to substitute your critical point into the second derivative with respect to y, square derivative with respect to y, times them two something here together. Then you can do the same thing, substitute your critical point into your cross partial derivative, square that answer. And if d is positive, it's one of two things. See here, d is greater than 0, d is greater than 0. So if d is positive, then you have to look at the value of f of xx. If f of xx is also positive, then you have a relative minimum. If f of xx is negative, you have a relative maximum. And if d is negative, you have a saddle point straight up. And if d equals 0, the question can't work, send it back to them. You're going to need other techniques to classify the critical point. So definitely your d will not come out to be equal to 0. One of these two. If d is positive, you have to go and check your f of xx. If your f of xx is positive, relative minimum. If it is negative, relative maximum. And once the d comes out to be equal to 0, you have a saddle point. That's all. Let me know if you're ready.
Because I can't, that's sir.
Yeah,
No,
man.
no,
Brain
man, no,
just
man.
melt.
All right, no, man. No,
First, go back to the first part, sir. Because the first part is crucial.
Mhm. Just waiting until Yannick so I can move.
All right, you can go on now, sir.
All right. All right, let's go. I'm finding a very simple question to go through. Now, do me a favor. Me not do phone number. Very sorry. Do know when you get something like this, and of course you have a word of word, but well, matter of fact, we're not even going to talk about the word of word yet. So you get a question like this, and it says, find the maximum point or the minimum point. What's the first 6 things you're going to be doing?
And cross order.
Okay, all right. So go ahead and do those 6 differentials for me now, please. I give you 5. No, I give it 3 minutes. 3 minutes.
I didn't hear the question, sir.
Go ahead and do the differential for me, please. F subscript x, 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 y, 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 x, y, y, x. Uh-huh. You not play at all. You're serious about this? I'm happy. All right, guys, one more minute, one more minute, one more minute. Beautiful. Look at it and tell me if you're free. ABC, very good. Autumn, very good.
Sir, I'm not getting it.
I mean, you're not getting it. Sash, you play too rough. What do you mean you're not getting it?
No, maybe what you made there.
Sir, how you get the 1?
Make your drink up so.
I just something naturally sound me that.
Drink your bad but a while ago. I nearly runs. All right, who I get the 1?
Yeah. Let me tone it down a bit. Sir, how did you get the 1?
All right, a little better. All right, that's one.
Yeah, man, that one there, the one for the last one. I'm gonna get it for the first
Where was
FXY,
Babylon?
but FYX, when I get the one day.
I get everything was, oh, you get the 1, sir, because you just have that plus that.
Why this online teaching us me? I'm multitasking. I'm listening to you. I'm responding to messages. I like the sound of it. I like the look of it. How I get the 1? How I get the 2? Never mind. All right, let's go. So we have a function. I'm differentiating with respect to x. 2x is what I have here. I'm differentiating with respect to x. It means my y is constant. So I put my y. Differential of x is 1. Put it there. There's no x here. There's no x here. Those two go to 0. So this is this. I'm going to be differentiate. Let me just differentiate this now with respect to x. Again, to get the f of xx. Differentiating 2x, I get 2. Differential of y is a constant 0. Let me differentiate this function with respect to y. So what I did was to find f subscript x, then y, then xx, then yy. All right. So f subscript y is going to be f subscript y. The differential of the x here is a constant, is 0. And when I differentiate it with respect to y, my x is a constant, I write it back. Differential of y is 1. 1 times x is this x. Differentiating this y squared, I'm going to get 2y. And differentiating this y, I'm going to get 1. When I differentiate this function now, with respect to y, this is a constant, it goes to 0. This is a constant, it goes to 0. Differential of 2y is 2. When I differentiate f xy, I go to f subscript x and differentiate it with respect to y. This is x, it goes to 0. Differential of y is 1. F subscript yx, I go to f subscript y and differentiate it with respect to x. Differential of x is 1. This is a constant, that is a constant. So I get 1, 1. So these two are the same.
Ah!
But guess what?
I see the light, sir.
But guess what? You know what I don't understand? And I don't want anybody to, I'm going to say something now. I don't want anybody to be upset with me. Me can't understand how you get that one here wrong. And this is the easiest question, the easiest differential since I start the topic that I've given you. Talk truth.
That's the problem, let's say. So it's some of the hard one you don't see so
hard,
you know.
Which is the point I'm making. This is the easiest one that we have done. You've never done any of those questions where f of xx and f of xy and yy and xy and yx come out to a whole number. You've never done one of those. Are the easiest question? Easiest question.
Sir, I'm overlook the last part.
Sure, man. We're supposed to charge you, you know. All right, let's go. All right. So, all right, before we go, are we all together? Are you agreeing? Are you understanding? Are you with me? Let me know. I don't want to move on. All right,
Yes.
very good. All right,
good,
here,
good.
Here it is.
Let's see what is simultaneous coming, sir.
Because you're going to have all right. Now, this is what is going to happen. So when you look at this here, when you look at this, you have all of that, and then remember now, they look a write up set. And even without I give it the write up. We know that when we're using a single variable function and we differentiate the single variable function, what it is that we're doing, we are setting the differential equals to 0. See here, so we're setting f subscript x and f subscript y equals 0. So hear me out. For stationary point, let 2x plus y equals 0. and I'm going to let x plus 2y plus 1 equals 0. And then we're going to solve both simultaneously. See them here? You're solving these simultaneously. You're solving these simultaneously. You put in this equals 0, which is the first differential with respect to x. And you put in this equals to 0, which is the first differential with respect to y. So you put in the first differentials, x and y. It's unique, boy. To get it. Send it equals to 0 in order to solve it simultaneously. And Sasha, sir, as to why getting a simultaneous, you are getting a simultaneous because you have two equations with two unknowns. You have two equations with two unknowns. Now, for the single variable function, you know that we had to factorize. We're not doing a factorization so much here, so it's mainly simultaneous equations you're going to work with. I'm going to tell you straight up. You're going to work with simultaneous equations. Simultaneous equations. All right? Let's go. Let's go. So what I'm going to do, I'm going to, what did I do? What I did was to, why did I do it like this, too, Lord? Oh, I use a substitution method. Okay. Using the SUBSTITUTIONMETHO. All right, so I'm using the substitution method. So what I did was to make y the subject of the formula by making y the subject. This would be JECT of EQUATION of equation 1. I'm making this y, and I'm going to call this one, and I'm going to call this one down here. So all right, so I'm going to subtract 2x from both sides, so y is going to be equal to negative 2x. Now, anywhere in the second equation I see x, I'm going to substitute negative 2x.
You mean why?
I said that to see if you're paying attention. Very good. Very nice. Anywhere in the second equation I see y, I'm going to substitute negative 2x. Very nice. So anywhere in equation 2, I see y, I'm going to substitute negative 2x. So this is going to be x, see it right here, so, plus 2y, 2y, so it's going to be 2 times negative 2x, see it right here, so, plus 1 equals 0. Now I have an equation in only x. So this is what is going to happen. X, 2 times negative 2 is negative 4x plus 1. X minus 4x is minus 3x plus 1. And when I do some basic algebra, I'm going to get x to be equal to 1/3. Take a minute and look back at this for me, please. I know you know what to do. Take a minute and look back at that for me, please. Thank you.
Sir, so the 2x plus y equals 0. What if the equation 1 would be like equation 2? Would
What
you
if it,
do that
all right,
substitution?
hold up, Sash. I'm gonna ask you to go again. You came across choppy.
You hear me now, sir?
Hold on a minute.
I check.
Go ahead. Hearing you now, loud and clear.
Okay, so I'm saying the substitution that you did with the equation 1, you had 2x plus y equals 0. What if it was like the second equation? How would you find that? Or is it going to be like this all the time?
No, I can't tell you that I can tell you. I can't tell you what it's going to be all the time. I don't know what the equations will work out to be. I have found a simple equation to give you, just to show you how it is that we apply the rules. The truth is, I can't tell you what the function that they will give you. Sometimes, and you can tell me this if you find the question already. Sometimes this function has 1, 2, 3, 4 terms. I have seen past paper questions with 5 and 6 terms in it to go ahead and do some stuff, right? I can't answer that last part. What I can say to you is that whenever you set your equations equals to 0, you'll be able to get either a critical value or critical values. I don't know if I'm answering what it is that you're asking me, but it is not stereotyped to see. Go ahead.
Yeah, so you found y to put in equation 2, right? So if it is that for example, equation 1 had 3 terms, you will do the
equation 2.
No, you would find the y if it had 3 terms, sir.
No. What I'm doing is just using. I can use the elimination method, but I don't know why it is that when I was doing a question, I decided to use the substitution method. What I'm saying to you is, I'm looking at the simpler of the 2 equations to make a substitution into the other equation.
Okay.
Right? So, but I could also use the elimination method, and you will see me use the elimination method some other time. All right? So
okay,
I'm just using one to do the other, right? And here again, now I'm going to be doing a substitution because I'm going to put x equals to to positive 1/3 into I'm using the first equation.
Okay.
So anywhere, and I could use any of the 2 equations as a matter of fact. So anywhere in the first equation I see x, I'm going to put a third. So it's 2x plus y equals 0. I'm going to say 2 times 1/3 plus y equals 0. 2 times 1/3 is 2/3 plus y equals 0. Y is equal to negative 2/3. So my critical point now will be 1/3 comma negative 2/3. Remember, one of them alone is a critical value. The pair together gives you a critical point. Oopsie, you don't want to see that yet. Take a minute and look through that for me, please. Just take a minute, look through that for me, and I will.
Scroll up a little bit, sir. Yeah, hold on.
Sir.
I'm hearing you.
But did you use a different method and get the same answer now? The same
Absolutely.
rotation.
So you're using the elimination method.
Yeah. But my worry is sometimes with the extra parts to it where you're finding 2 critical points or more, I tend to get flustered and mess up that work, you know.
You're not alone. Trust me. Your teachers sometimes get confused. I could have started with a question like that, but what I don't want to do I can't bother with ABC, I can't bother with slash, I can't bother with your need, and I can't just say, but sir, no man. What I'm doing is
Sir, but we know say it a come, you can't trick it.
No, I'm not
But
tricking
thank
you.
you for gently easing us into
Oh,
it.
bless the Lord, yeah, man. So I'm just trying to navigate through the question, and then, as I said before, based on what Sash asked me a while ago, I honestly cannot tell you what function they're going to give you. All I can tell you is I'm teaching you conceptually. Now, this particular question has just one critical point. There are other questions that will give you multiple critical points. All right. I have a question here that gave 4 critical points. Now I can't start off a question, the topic with that question. I'm going to scare you, right? So I'm starting off with this with 1 critical point, then I can move on with 2 critical points and 3 critical points and 4 critical points, because I don't know how many critical points Sash the exam is going to give you. But guess what? I guarantee you that when you get a question such as this, you are going to go ahead and you are going to do your 6 differentials. X, 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 y, 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 x, y, y, x. You're going to substitute, you're going to set x and y equals 0. You're going to solve those simultaneously. You can choose the elimination method. You can choose the simultaneous the substitution method. You get your critical value, substitute your critical value into any of the equations to get the corresponding values to get your critical points. When you get your critical points, this is where we are now. Remember this formula? F of x times f of y minus f of xy all squares. But sir, if I put f of y x all squares, it will be the same thing? Yeah, duh, because we got those to be the same. Watch me. I have my critical value. My critical points, I'm sorry. My critical point, since it's just 1. My critical point. So watch what I'm doing. For my critical point, what I'm doing here is my f of xx. Remember, f of xx was 2. So, oh, sir, that means you don't have to substitute 1/3 and negative 2/3. Absolutely, because it's a whole number 2. So this is going to be 2. The f of y is also 2. So it's going to be 2 times 2. See it right here, so minus f of xy is 1. So it's going to be 1 squared. So 2 times 2 is 4 minus 1 is 3. No, d is 3. Is positive. D is positive and it is 3. But f of xx is also positive. So both are positive. So that means you have a relative minimum. End of question. Tell me if this piece here hard.
So it's like an explanation you're doing then, sir.
Yeah. Yeah, man. So I get a relative minimum. How you feel?
This might be my range, sir.
No, it's not going to be. I bind that.
I'll look it over. Over.
All right. So guess what now? I know you know what to do. See another question down here. So I don't want to go any further because I want to keep this projected.
Last answer.
Let me write down that there first.
No, that's what I'm doing. I'm just reducing something here. Come in. I'm just reducing it so that you can.
Sure.
Yes, honey.
The D. Go back over that part. That's me again.
So I'm saying to you, when D is positive, it could be either a relative maximum or a relative minimum. How do we differentiate that now? If D is positive, how do we differentiate the maximum or the minimum? We have to look at f of xx. If the value of f of xx is positive, you have a relative minimum. The value of f of xx is negative, you have a relative maximum. Say it again, bigify it.
Yeah. Yeah.
If f of xx is positive, you have a relative minimum. If f of xx is negative, you have a relative maximum. And if D works out to be a negative value, you have a saddle point. So if D is negative, straight up saddle point. But if D is positive, you have to now look at your f of xx to see exactly what sign it is. If your f of xx is positive, you have a relative minimum, like this one here, relative minimum. But if f of xx were negative, you'd have had a relative maximum.
Okay, so you'd fit those 2's and 1's in the equation.
Here you go. Here you go. All right, I have another question here, please. Start with this one, and then Johnny, see if you can find that past paper for me, please, in the meantime. But I want you to work on this one for me as a classwork. Do know I give you 5 minutes.
No, sir.
What do you mean no? Of course. You're not here for your pretty looks. Come to the question, man. Hello, you shouldn't be asking me this. It's all right. Watch your phone. On the market, set full start, please.
Sir,
Yes, dearest.
so after you find the critical point, right, where you incorporate it in the formula, it basically does serve a purpose in the working out that is.
Very good. So I have a critical point, but in this critical point here, don't serve a purpose for this question. Why? Because my f of x and xy and yx don't have a variable right there.
I had that
Good,
question in my head too.
good observation.
Oh,
Good observation.
okay.
So if I had this to be 2x, it means that I have to substitute the 1/3 because the 1/3 represents x and the negative 2/3 represent y. So if I had this as 2xy, it would be 2 times 1/3 times negative 2/3. You follow me?
Yes, sir.
Got you. Nice.
Sir, we're not relying on Stephen. And me, I know, sir. Honestly.
No, because one very one somebody who is very who is almost a cousin is telling me the same something, the same story. Lord, sir, me tired, I'm want to sleep. Me sorry for that. Because guess what? I must finish. Well, I'm finished with this topic. It's just you doing this stuff on your own because the topic finished. There's one other order of the day. I'm going to use a few to do a question. Yannick, you find a question for me, please, honey? Me know I'm tired, but this is going to be the
Which
sacrifice.
one?
The one with the whole
the
word of word of.
the maths one with me that the accounts one with me that talk about.
Yeah, man. Find out post it to the group one, please, son.
Hey, sir.
Yes, Papa.
Alright, so from me to the substitution, me stuck.
All right then. All right. Let's go. I know it has Sash, but guess what? It's push along. Do you all have this?
I have it,
T?
sir.
Nice.
Yes, sir.
So you're setting the first differentials, x and y to be equal to 0.
Me not have nothing like that.
Don't no. Guess
Our
what?
mother.
Don't worry. Oh, me do my something right here, so. Because me don't know what me do either. Oh yeah. I know what I do. So I'm solving by the elimination method this time. That's what I said. We're going to use both methods. Solving using the elimination method. So what I'm doing here is to multiply. Okay, so I'm eliminating the x's. So you see that this x here is a 2 and down here is a 3. So I'm going to multiply this equation by 3 and multiply this equation by 2. So I'm crisscrossing the coefficient of x so that when I multiply, see here, so I'm multiplying equation 1 by 3. So or you just get 3 out of the bag. And not out of the bag. I'm look on the coefficient down here. So and I'm multiplying equation 1 by this 3. And then I'm going to multiply equation 2 by this. By the 2 here. Why, sir? See here, so I'm doing that so that when I say 3 times 2, I get 6x, and 2 times 3x, I get 6x. So both of these x's are the same. Now, since they're the same, I can subtract and eliminate. That's why I'm using the elimination method. I'm using the elimination method. All right. So when I do that multiplication, this 3 is going to be affecting everything here. So 3 times 3y is going to be 9y, and 3 times 0 is 0, and 2 times 2 is 4y. So I'm going to have this equation here. So when I subtract SUBTRAC, subtracting equation 4 from 3, right? So I'm subtracting equation 4 from 3. And when I do that, I'm going to say, when I subtract 4 from 3, I'm really saying 3 minus 4, don't it? So 6x minus 6x is 0, and 9y minus 4y is 5y, and 0 minus 0 is 0. So we have 5y equals 0, therefore y equals 0. Take a minute and look at that, please.
Sir, the 3 and the 2, where you get those, sir? In the elimination.
The 3 and the 2. Oh, yeah, that's what I just explained. So because there's nothing common, I'm using the elimination method, and there is nothing common to the coefficients are different. I am now multiplying, I'm crisscrossing the coefficients for the variable that I want to eliminate so that I can go ahead and eliminate it. So I am multiplying the top one by 3 and the bottom one by 2, or vice versa. You follow what I'm saying? No? Yeah?
Let me look into it, sir.
No, stop. Come, let's go. So I'm saying to you, we're given 2x plus 3y equals 0, and 3x plus 2y equals 0. All right? So there is nothing that is, when I look at my x's, there are different values. When I look at my y's, there are different values. But if I'm using the elimination method, I now need to decide which of the variables to eliminate. I want to eliminate my x's. So in order for me to eliminate the x's, if I were to subtract, I'm not going to get 0. If I were to add, I'm not going to get 0. So I'm going to multiply by a scalar quantity. Multiply by a scalar quantity, don't change it. KFC can make 1 tray of chicken in the oven. And KFC can also make 5 trays of chicken. I can bake 1 dozen cookies, but I can rescale the recipe and get 6 cookies, or even 3 cookies, or even 5 cookies. It don't have to be an even number, or 7 cookies. All right. So what I'm doing is, because I have a 2x here and a 3x on here, I'm multiplying, I'm crisscrossing the coefficients of my x. Then, sir, what if I want to eliminate the y's? Okay, fine. I would multiply the first equation by 2 and the second equation by 3. So when I crisscross the coefficients of the variable that I'm trying to eliminate, I will end up getting the variables to be the same number now, or the same coefficient. So with the variable with the same coefficients. So what is going to happen now? I can now subtract. I can now subtract. And if one of them were negative, I would just go ahead and add. So it is that I'm now able to eliminate my x's.
Get it now, sir.
Good job. All right. So I'm going to put y equals 0 into any of the 2 equations. I'm going to put y equals 0 into any of the 2 equations. And when I do that, I'm going to get 2x equals 0. So x is also equal to 0. Rockstone. So my critical point is 0, 0. My critical point is 0, 0. Then, sir, you can have a critical point being 0, 0? Yeah. Critical point is 0, 0. F of x times f of y minus f of xy all squares. F of x times f of y minus f of xy all squares. Recall. These were the values of f of x, the value for f of y, and the value for f of xy, which of course is equal to yx. All right, and then look at the substitution and tell me if you see it.
Yes, sir.
Nice.
So when you said it becomes a saddle point, what do you say after that?
The value of d is going to be negative.
So it stops right there.
Done.
Yes, sir.
Yes, yes.
It stops, right?
Yes, son.
Okay.
So I'm send out 2 questions, yeah?
Yeah, man, I saw them. I just want to talk briefly about them. I just want the others to
One question.
go ahead. Go ahead, please.
All right, sir. I make one note. So let me just confirm what I did say before. So if d equals negative, if d is a negative, it's a saddle point. If d is a positive, but f of x is a positive as well, it's a minimum. And if f of x is a negative, it's a maximum, right?
Mm-hmm.
All right.
Hold on.
XX.
Right. Okay.
Yeah.
Good.
Scroll a little up, please. Scroll up, please. Yes.
So you see that is a saddle point here because right at the back, when you substitute into the formula f of xx times f of y minus f of xy, you got a negative value. You don't need to check no f of xx this time because once d is negative, bam, saddle point. Bam, saddle point. All right. Any questions?
Yes, sir. I'm not sure if you're hearing me. My Wi-Fi keeps cutting out.
Okay.
Sir, question. If when we were substituting, we did not times it by the numbers to get them equal, and we just go ahead and minus, we would have
That
get the
mean-
negative.
Yeah, you wouldn't be able to you wouldn't be able to solve the question using the elimination method. You trust me. The question you wouldn't be able to get a value of x or y and to solve simultaneously.
No, sir, but when we did sorry, I'm not talking about the substitute, the substitution, using the evaluation, the same one that you did, sir, but leaving out the times. If you decide to minus it without times by the 2, you get negative x plus y equals 0. If I went ahead to
stop.
just take out y.
No.
That's all, sir. There you go.
Listen to me. You want me to fall out? No. Remember, no, you can't solve an equation. I mean, I use the word an, it is singular. I can't solve an equation with 2 unknowns. And if you recognize what it is that you said, I would have had negative x plus 5 equals 0. That is an equation, one equation with 2 unknowns. Impossible. Impossible. Impossible.
But wait, sir, what I am saying, you'd get negative x plus y equals 0. So, sir, could you not say x equal, then therefore x would equal to 0 and y would equal to 0?
Anika, direct message me and tell me where you work so I can come to your workplace and shake out your lunch money. So tomorrow's Friday, so I can go to Port Royal, go buy 2 lobster and eat. No, Nika, you can't do that. Nope, it's illegal. The pawpaws will come for you. The pawpaws will come for you. But I want you to get me, guys. So I hear what she's saying. But what she's going to end up with is an equation with 2 unknowns. An equation with 2 unknowns. I cannot solve an equation with 2 unknowns. No. What, sir, when I did this, I get the 0, 0, sir. Illegal. Can't do it. You get me, honey?
Okay, sir.
Thank you, sweetie. All right. I know it's scroll down. I know it's 10, and I know there are some of you here who say, "Oh, I want to go," but I just want to take about 2 more minutes to show you something. I'm happy that I got through the stuff, and for you to see how it is. And you did 2 questions on your own. I did 1 with you. I just want to show you something so I can leave you to do these questions that you need put in the group. 10 minutes finish, Sash. Waiting on you.
Hey, Ken.
All right. Let me see how I can do this now. where am I going? I'm going to, where am I going? Where am I going? Where am I going, guys? Calculus 2. Okay, I'm right here. Calculus 2. New share. All right, so let's just look at share. Them alone cute. All right, look at this. All right, so find the first order partial derivative of the following follower class. What the fuck? All right, so this question here carries 10 marks. This question here carries 10 marks. All right. I'm just explaining it. I'm not going to spend the time in class to do it with you. I'm just going to explain it. It says the annual labor and automated equipment cost in millions of dollars for a company's production of television sets is given by C of XY, same thing as F of XY. That's just the name of this formula. C of XY, a multivariable function, is equal to 2x squared plus 2xy plus 3y squared minus 16x plus 18y plus 54. 1, 2, 3, 4, 5, 6. I did say to you that sometimes it goes to 5 or 6 terms. All right, this one has 6. Where X is the amount spent per year on labor, and Y is the amount spent per year on automated equipment, both in millions of dollars. Determine how much should be spent on each year to minimize this cost. Now, the mere fact that I said to minimize, it means that your f of x is going to come out positive because they're telling you that it's a minimum. They are actually telling you that it's a minimum. So it means that your d is going to come out to be positive and your f of x is going to be coming out to be positive as a relative minimum. So you're going to determine how much should be spent on each. So your critical point is going to be telling you how much you spend on each. Oh, the x value, sir, in the critical point to tell you the amount spent per year on labor, and the y value in the critical point, sir, will tell you the amount spent per year on automated equipment, and both are in millions of dollars. Yes. What is the minimum cost? When you get the minimum value, the critical point, you substitute it into the original function. C, therefore, is the cost function. So the cost function with respect to x and y is given by this. See here, the annual labor and automated equipment cost. So therefore, this is a cost function. Easy 10 marks. Tell me if you see what I just explained.
So you just explained what we just did then.
I just explained on what?
What we just did.
Absolutely. Absolutely. So when you get this question, f of c subscript x, c subscript xx, c subscript y, c subscript yy. All right? 2x squared plus 2xy, 2x squared plus 2xy. Hold on there. 2x squared plus 2x.
Sorry, so part 2 would just be the answer that we get for D?
No, part 2 is going to be when you're going to substitute the original into the function. The original into the function. Into the cost function. Is that the question?
So you're right by the function and then put the critical point back which by x and y there. Oh,
Is this a question?
Yeah, that's the same question.
Okay. So you're going to find the function. It's finding c subscript x of xx, y, yy, xy, yx. You can solve simultaneously. You put the c of x equals 0, the c of y equals 0. This one, you're going to get the same simultaneous equation. I'm going to use the same method. I'm using, look at this. One, I'm going to get 4x plus 2y equals 16 and 2x plus 6y equals 18. I'm going to multiply this equation alone by 2 so that I can get the two of them with the same something, or multiply by -2. So I can go ahead and add, just revise simultaneous equation. Just revise the simultaneous equation. When I do that, I'm going to get y equals 2, x equals 3. So I'm going to get this as my critical point. So the critical point is given by 3, 2. But remember, the question did say that it's in millions of dollars. So this now is going to be $3 million and $2 million. But you have to remember what X is. It says X is the amount spent per year on labor. So this is going to be $3 million, because that is X, $3 million spent on labor, while $2 million spent on automated equipment, right? And then it is saying, oh, we need to classify. We need to classify. When we classify the stuff, we know what X, Y, and XY is, or are. We know it's f of x times f of y times f of xy all squares. See x here, there is no x values or y values to substitute the 3 and 2. So it's going to be 6 times 4 is 24. 24 minus 2 squares is going to be 20. So I get 20. It is positive, and f of x is also positive. But I could have read the question and told you that it is going to be positive because why? And it's a relative minimum. Why? Because the question says, determine how much should be spent on each year to minimize the cost, not to maximize, but to minimize. So in order for me to get a relative minimum, it means that D has to be positive and f of x must be positive, right? So in my mind, when I start the question, that's exactly what I'm going to be doing. See it here. D came out to be positive, and C of x is positive, so I have my relative minimum. Now, the second part of the question is using my, what do you call it? My critical point, my 3,2, see here, and substitute it into the cost function. Now I'm going to get 12. So the minimum cost is going to be $12 million. You tell me if those 10 marks are not easy marks to get.
I know we should have 20 marks here.
That should be more marks.
And to be honest with you, I'm kind of disappointed when them give 10 marks to that. I'm kind of disappointed. But is this anything different from what it is that I would have taught you tonight in class?
No, sir.
And,
sir, make we discuss the 30 marks one, no?
And guess what? My final question for the night. Did I lie to you about the question?
No, sir.
I don't think I did.
No, sir.
I don't think I did. No, mark you. And I don't want anybody to leave and say, sir, you never lied last week, but you lied this week. I don't know what this function will be like. I can tell you, I can give you a question where it is that you're going to get 4 critical points, or 3 critical points, or 2 critical points. But in this case, based on the construct of this question, you are going to be given 1 critical point. And when I read it, I knew I was going to get 1 critical point. All right. So even though it's a lot of word up, you do the thing and you're good to go, and it makes sense. So what I'm saying to you is, you are in the business of selling computers and printers. You no need to find out what your cost function is. You can generate your cost function, and you have your cost function. You can say, how can I minimize? How can I maximize? And you work it. This is how places like people like Toyota and Mercedes and BMWs do this stuff. The man them call you and say, here the plan, Mr. Lexton, you're invited to the board meeting. I need to make a presentation as our projected cost for this fiscal year. You say, Rockstone, what is the projected cost? We need to make at least $1 billion in profit for the first quarter. Jeez, Father, quarter, sir? That are 3 months? Yeah. So Lexon have to go and say, okay, the Toyota Camrys are the best-selling cars. So we need to know manufacture and ship out to these countries, and we're going to be selling X amount of cars. So when Lexon goes, he can do the calculation and come out and say, well, our estimated profit for the first quarter, sir, we did not get the $1 billion, but we can say to you, sir, based on the pandemic, this is a projected thing, $12 million. No, go back to the board, go back, and then you go back and say, okay, we can't manufacture this number and this number. It has to be quadrupled in order for you to make $1 billion. All right. So this is how you do things, and this is how practical mathematics is. Have a good night.
All right, good night, sir.
All right, sir.
Remember to send me
Night, sir.
I'm going to send, good night. I'm going to send this off to you tonight.
No,
along,
sir.
along with the solution to the question that we'll look at it. Or you want me to not send the solution to this, so you want to try it on your own first?
Sir, you can send it so we can know if may work it, right?
Okay, I will do that for you, dearest. Thanks again.
Sir, you're sending this document tonight?
I'm going to send it tonight, yeah.
Okay, cool stuff.
Bless your heart, take care. Safe prayers.
All right.